Hello, I had a question from Unit 4, Lesson 2, Number 8 from the graphing. So whenever I approach these again, I always find the first derivative of a function. So I'm going to use quotient rule here. So y prime would be 2x multiplied by my denominator minus my numerator multiplied by derivative of denominator over x to the 6th. Simplifying that, I get 2x to the 4th minus, got to use distributive law here, 3x to the 4th plus 3x squared over x to the 6th. I'm going to clean that up. So we end up with negative x to the 4th plus 3x squared over x to the 6th. And we can factor out an x squared here just to reduce it. So we end up with negative x squared plus 3 over x to the 4th. So when I'm doing my graphing, again, first derivative is going to locate my max mins. So I'm going to use that to find my max mins. And again, you can also identify your inflection points. So at this point, I just want to see what a max min looks like. So this is where we let y prime equals 0. So that means that the numerator will be 0, negative x squared plus 3 equals 0, x squared equals 3, x equals plus or minus root 3. So I'm going to plug that into the calculator and get my two max min, or IP points, depending. So therefore, I'll have root 3 and negative root 3. And from the calculator, we get 0.38 and negative 0.38 when I plug it into the original equation. So root 3 is approximately 1.7, so I'm going to do my best here graphing that. So 1.7 positive and up 0.4, so I'm going to put it right there. Similarly on the other side, from symmetry, it is going to be right about there, let's call it. So those are either inflection points or max mins. I'm hoping I'll be able to tell based on the other information I'm going to collect here. All right, so on to the next one. I'm going to get my x and y intercepts, which will help me determine exactly what this graph's going to do. So for x-intercept, we let y equals 0, the original function. Numerator doesn't matter, it's the denominator doesn't matter, it's the numerator which is important. That factors, it's a difference of squares. So therefore, my x-intercepts are at plus and minus 1. So I'll add that information on. So I got this, and I've got this. So there are my x-intercepts. Let's look at my y-intercepts. This is where I let x equals 0. And in this case, I'm going to have 0 over 0. So 0 over 0, so therefore there are none. And this is going to make sense because when I check my vertical asymptote, x cubed equals 0. So that's where you let your denominator equal 0. We have a vertical asymptote at x equals 0. So draw that in. Technology. So there's my vertical asymptote. All right, so now I need to know my end behavior side to side here. So I'm going to find my horizontal asymptote. So this is where we do the limit as x approaches infinity for x squared minus 1 over x cubed. I'm going to divide everything by x cubed. And when I do that, that term goes to 0, that term goes to 0, that term goes to 1. I'm left with 0 over 1, or 0. So I have a horizontal asymptote at the origin. So now I need to figure out which direction am I looking at here in terms of the graph. Now, the hint here is that I got to cross the x-axis. And those 2 points here and here are either maxes or mins. So when I'm looking at this, I have to exit either here or here, and I have to exit either here or here on top or below the horizontal asymptote. It's not like I can head off in that direction. So that being said, it kind of matches up with if this has to be a max or a min, and if this has to be a max or a min, it'd be the highest point which means I'm going to have to exit this way because I can't cross the x-axis again. Similarly, I can't cross the x-axis over here. Finishing this up, when we're looking at our x-intercepts, I can't cross them again. My only choice is to exit that direction and that direction. So from your grade 12 course in the advanced functions, it should give you enough, you should have had enough experience to kind of talk your way through with the provided information. You can do your end behavior, doing your one-sided limited analysis. So for example, I could have looked at the limit of this function as we approach 0 from the negative side. Could have done it as it approaches from the positive side, all right, to help figure out where I'm exiting. All right. If you have any further questions with that, let me know, and I'll see what I can do to help you out.